very important. X minus 3 divided by x squared. What is my squared? Okay, plus 2x and minus 15. Okay, so the standard viewing window is still good. We know we expect a vertical asymptote at -5, a cross at 0,1/5, a hold which will not show if you don't know what it is. Now, that's a very good point. If you try to put this function, the simplified form, that would be wrong, because you're not graphing what you should be graphing. So do not put the simplified form in there. You have to put the original. Okay, so I'm going to clear this. So when you graph, please do not copy something like this, because I know when a student copies something like this, I know the student did not understand and did not do the correct work, or the step-by-step work. The function cannot stop here. The function goes all the way to infinity. The function cannot stop here. These are the problems or the tolerances of the calculator, right? So be careful. Do not copy something like this. And it does not overlap with the x-axis. No. And the hole is somewhere in here, right, when x is 3. So I'm going to change the viewing window so that I can show you this particular area. So I'll change to 1 to 4, and the y minimum 0, and y maximum 1. I'm only zooming in that particular area, and now I can see it. It's a little blip. So this is 1, 2, and 3, and you see it. It's an open point, but you will not see it otherwise. So you need to know what you're looking at. So again, do not copy something like this. Okay? Always think you know way more than the calculator does. Okay, so real quick, so we can finish this, let's look at any problem in which we are asked to evaluate, find a domain, no graphing. As you see, it takes a while to graph these functions. So in the word problems, we know what to expect. So let's see, what time is it? So, okay, we have 7 minutes, so that's good. I don't know what you are interested in.
57.
Say it again.
57.
Value of a stock. Okay, perfect. Let's do that. Again, I'm not going to ask you to graph these functions. Please don't. The value in dollars of one share. So find a main range. That's fine. So this is what we really want. So look at asymptotes and the intervals of concavity, opening upwards, downward. So we want to look at the first derivative, second derivative, and of course find the domain. Okay, so let's copy the problem. We have 57, v of t, 50 minus 15 e to negative 0.035 t. Okay, perfect. Good. So when we look at this function, so remember t is time, t weeks, so in weeks. After it was what? Fine. So whenever I start, if I want to graph or study or summarize the information, the domain is already given to us. I cannot consider, although in this function you can plug in anything you want, but whenever I am told weeks, I cannot go beyond to the left of 0, right? So this will be v of t, and we'll see if we need any of this. So that's established to be the domain by the moment they said to us weeks. In order to find concavity, we have to find the first derivative, and then we have to find the second derivative. I cannot jump directly to the second derivative. I have to find the first in order to find the second. And the second one will give us concavity, if it opens upward or if it opens downward. Okay, so let's find the first derivative. 50 prime is 0. I have a negative 15, but I have to multiply by a negative number, so I'm going to write 15 times 0.035 and times e to negative 0.035t. That's how we differentiate e to a function. E to a function prime is e to the function times the function prime, but this prime is negative 0.035, and I had 15 in front. So I'm just going to multiply, what is that, 15 times 0.035. I got 0.525 e to negative 0.035 t. Okay. Next, I have to find the second derivative by differentiating again. So the second derivative will be now negative 0.525 times 0.035 e to negative 0.035t. And now I have to multiply these two. And I had this times 0.035, and I got I mean, who wants to graph something like this, really? I'm not going to force you to do that. There's nothing wrong with it. It's just it's going to take forever to find points and so on and so forth. Okay, good. So now at this point, we simply want to study the sign. So this will never be 0. And you can say, how do you know that it will never be 0? Because e to a negative number will go to the denominator. And this is always a positive number. How do I know? Look at the graph. Right? So it's a number less than 0, so I mean between 0 and 1. So it will be a decreasing function, but it will always be positive. Again, how do you know? Because it's e to if you just look at 0.035t, right? So just because the coefficient, the power is less than, well, e2, in any event, what I meant to say is that it's always positive, even if it turns out to be increasing. It's really not the choice, not a problem. This will always be a positive number, no matter what value you plug in t. This will always be positive. Now, what is the sign of this expression then, if this is always positive? What is the sign of this expression, or the second derivative? This is the second derivative. What is its sign?
Negative.
Yes, because it's negative, we know that the function will always be concave downward. The function, v of t. So the answer for list any intervals where the graph of v is concave up or down, the answer is very clear. It's always concave down. So the interval, and I'm going to write this, concave down on its domain forever. On 0 to infinity. Always concave down. Because the second derivative has positive in the denominator, and this number is negative. If this number were positive, I would have said positive, but it's a negative number. So negative of a positive, it will always be negative. Now, any asymptotes, and explain their significance. So we have to determine limits. So this function is always defined. However, we have to determine the limit at infinity, not at negative infinity, because we're talking about weeks. So in order to find any asymptotes, this function is defined everywhere. It will not have vertical asymptotes, but I have to determine whether it has horizontal asymptotes. So that part is also easy. So I have limit from 50 minus 15 e to negative 0.035t only when x approaches infinity. And we've done this before. So, sorry. When t approaches infinity. So if t approaches infinity, where is this going? Just this piece. Where is this going? When t approaches infinity.
Negative.
Yes, but negative infinity. Good. So this approaches negative infinity. Good. Where is this going then? E to this number, e to negative infinity. Where is this going?
The same.
Careful. E to negative infinity is 1 over e to infinity. Where is this going?
Infinity.
Careful. I have a pie, and I want to share it with billions of people. How much will you get?
Oh, 0.
Excellent. How much is 0 times 15?
0,
Perfect. So then what is the limit?
50.
50. Which means y equals 50 is a horizontal asymptote at infinity.